Hi guys, it's Mrs. Seitz, and today what you're going to be learning is a different property of exponents, actually two. You're going to be learning when you have a zero as an exponent and what happens when you need to do when you have negative exponents. So as before, you learned what actual exponents are. So when you have like 3 to the fourth power, the power of 4 means you actually have 4 copies of 3. So 3 times 3 times 3 times 3 would give you 81. 3 copies of 3 would be 27, and so on. Well, if we actually follow this model, we can actually figure out what 3 to the 0 power is. So if I would keep going and going here, we can see that each one of these are actually decreasing by a power of 3. So when that happens, you can notice 81 divided by 3 would give us 27, or 3 to the third power. 27 divided by 3 would give us 9, or 3 to the second power. And 9 divided by 3 would be 3, or 3 to the first power. If I actually divided by 3 one more time, I'd get our answer for 3 to the 0 power. So 3 divided by 3 would give us 1. So anytime we have an exponent with a power of 0, and this happens for anything, anytime you have a variable or any type of number that's raised to a power of 0, the answer is always going to be equal to 1. So if you had 6 raised to a power of 0, the answer would be 1. If we had -5, the quantity of -5 raised to a power of 0, it would be 1. If you had 912 to the power of 0, the answer would be 1. We can also continue that pattern that we had before to kind of figure out also what happens with negative exponents as well. So we learned before that if we kept on dividing by 3, we could see that 3 to the 0 power was equal to 1. Well, I can see now that I actually can go into the negatives with my exponents as well. So if I kept on dividing by 3, 1 divided by 3 is 1/3. That would give me a relationship now. 3 to the -1 gives me 1/3. Then if I continue to divide here by 3, and you can even punch that in your calculator, but I remember before I can't just simply just divide by a fraction. I'd have to keep it, change it, and then flip this guy. So let's see, 3 to the -2, if I divided by 1/3 or divided by 3 one more time, that would turn into 1/9. And then if I divided by 3 one more time, so if I had 3 to the -2 was equal to 1/9, and I divided by 3 again, remember I can't just divide straight across. I would have to keep it, change it, and flip it. So that would turn into 1 over 27. So 3 to the -3rd would be 1 over 27. So what's happening here is as I get a negative exponent, I always have a 1 in the numerator, and that number now is in the denominator. So it seems like what's happening is I now have almost a reciprocal of the numbers that I have in the top. And that's actually what happens when you have a negative exponent. Anytime you have a negative exponent, it's always going to be the reciprocal of the positive. And when I say the word reciprocal, just to make sure you understand, a reciprocal in math would mean like flipping a fraction around. So for example, if you had 1/3, the reciprocal means to flip your fraction. So the reciprocal of 1/3 would be 3 over 1. If I said to you, what's the reciprocal of 4? You'd have to put a 1 underneath it, and the reciprocal of 4 would be 1/4. So if I asked you to give me the reciprocal of this a to the -n, you'd have to make it into a fraction first by putting a 1 underneath it. And then anytime we have a negative exponent, we have to fix it by making it into a positive exponent. So we flip it and make it into a positive exponent. Okay, so for example, if I have 6 to the -2, I'm going to make it into a fraction first by putting a 1 underneath it. I have to get rid of my negative exponent by flipping my fraction around. And when I flip it, it makes my exponent positive. So instead of it being 6 to the negative 2, it's now going to be 1 over 6 to the second. Then I would simplify anything that I can. And I know 6 times 6, or 2 copies of 6, would give me 36. So that means 6 to the negative 2 would give me 1 over 36. I'm going to do the same thing for the second example. I have 4 to the negative 5th. So I'm going to put a 1 underneath it, and I'm going to flip it. So it becomes 1 over 4 to the 5th power. That means I want 5 copies of 4. So I'm going to do that right here on my calculator. So I want 4 to the 5th power. That's 1024. So my final answer would be 1 over 1024. Okay, and again, it also works for variables too. If you put a 1 underneath it and you flip it, when you flip it, that exponent becomes positive. That's the whole point in doing that. So your final answer would be 1 over y to the 7th power. All right, now let's practice a couple of these. You can see that some of them have negative exponents, some of them have a mixture, some of them have some rules that we've learned before. So in question number 1, I'm going to put a 1 underneath it, and I'm going to flip it to make it positive. I'm going to simplify the 3 to the 4th power. So 3 to the 4th power is 81. So that means my final answer is going to be 1 over 81 for question number 1. For question number 2, I learned in this lesson that anything raised to the 0 power is 1. So the final answer for question number 2 is 1. In question number 3, this is a blast from your past. If you have the same base, you're going to keep your base and you're going to add your exponents together. So if you have negative 3 plus 3, that's going to give you a 0. And we learned anything raised to the 0 power is just going to be 1. So your final answer for question number 3 is 1. All right, let's do the same thing for question number 4. I'm going to keep my base of 10, and I'm going to add my exponents together. So 4 plus negative 6 is going to give me 10 to the negative 2, but now I need to fix that. So I'm going to put a 1 underneath it, and I'm going to flip it. So that will become 1 over 10, but when I do that, it's going to become a positive exponent to the 2nd power. And I'm going to now simplify 10 to the 2nd power, or 2 copies of 10, to make that 1 over 100. So the answer for question number 4 would be 1 over 100. For question number 5, I'm going to put that down here. This is like 1 copy of 7. So I would keep my base of 7, and I would add the 1 and the negative 3. So 1 plus negative 3 is going to give me negative 2. So again, I'm going to need to fix that. So I'm going to put a 1 underneath it and flip it. So it becomes 1 over 7 to the 2nd. And my last step is I'm going to simplify 7 to the 2nd power, or 2 copies of 7, which is going to give me 49. So final answer for question number 5 is 1 over 49. Okay, for question number 6, this is really like 12 to the 1st power times 12 to the negative 1st power. So I would keep my base of 12, and I would add 1 plus negative 1, which means that I would get a power of 0, and we know anything raised to the 0 power is just going to be 1. All right, and then for question number 7, sorry for running out of room there, but on question number 7, we have that power of a power that we learned before. So when that rule happens, you keep your base of 4, and you multiply your exponents together. So negative 2 times 2 will give you negative 4, but now we need to fix the negative exponent. So we're going to keep it on a 1 underneath it, and we're going to flip it to make it positive. So 1 over 4 to the 4th power. And now we're going to simplify what 4 to the 4th power is. So 4 to the 4th power gives me 256. So 1 over 256 will be the final answer for question 7. Number 8 is very similar. We have a power of a power. So keep the 5. And now we're going to multiply the exponents. 2 times negative 3 is negative 6. Put it over 1 and flip it. So it becomes 1 over 5 to the 6th. And then we're going to have to simplify 5 to the 6th power. So the answer would be 1 over 15,625. Okay, so now what we're going to do is we're going to take a look and see what would happen if we actually had some problems that were not set up just as numbers like these ones, but actually would be set up like a fraction like these. What happens if you have a negative exponent there? Well, if that would happen, these problems are actually a little bit easier. Instead, what you would have to do is you'd have to move the floor, I call them the floor of the fraction, to simplify your negative exponent. So what that means is if a negative exponent is in the numerator of a fraction, then you need to move it to the denominator and make the exponent positive. So we no longer would need to put the 1 underneath it and flip it. All you would need to do is just move the floor. If a negative exponent is in the denominator of a fraction, move it to the numerator and make the exponent positive. Another important rule is to only move terms that have negative exponents. You want to make sure that you keep terms with positive exponents exactly where they are. All right, so here's what I mean. So if you take a look at the first example, it's already set up as a fraction, so we don't need to put ones underneath anything and flip in that respect. Instead, if you look at that x to the negative 2, that's the only thing in the problem that has a negative exponent. Since it's in the numerator, we want to move it to the denominator. So I'm going to set this problem up with the fraction bar. I'm going to leave the y to the 10th power in the denominator because it has a positive exponent already. I'm only going to move the x to the negative 2 into the denominator and make it positive because it had a negative exponent. If I take everything out of the numerator and there's nothing left over, I'm going to put a 1 as a placeholder. If you wanted to write your final answer with your x's first and then your y's, so everything's in alphabetical order, you can, but that would be your final answer. Okay, let's try one more. Okay, let's take a look at problem number 2. In this problem, I see that 2 has a negative exponent, and I see that a c has a negative exponent in the numerator. So I'm going to set this up with my fraction bar. I'm going to move the 2 down into the denominator with a positive exponent, and I'm going to put the c into the denominator with a positive exponent. The a to the 4th power already has a positive exponent, so I'm going to leave it in the numerator. In the denominator, I already have a b to the negative 10, so it needs to move from the denominator up to the numerator. So I'm going to move the b to the negative 10 to the numerator and make it into a positive exponent. So now that I look at everything, I need to double check to see if anything else needs to simplify. And the only thing I see is that 2 to the first power should probably just simplify down to a 2. So I'm going to write that as a 2 and then write everything else as is. So a to the fourth, b to the 10th, a 2, and then c to the 7th. So again, when you have these negative exponents and you have it already set up as a fraction, you're just moving the floor of the fraction. So let's see if you guys can do this. In this problem, or in these problems, they're all set up already as fractions. So see if you can practice moving these around to set these up correctly. So again, the only factor that has a negative exponent is the x. So in the first one, we're going to write everything, the -4, the x to the second, and the 2 in the same exact spots. The only thing that needs to move is the x to the -1 would go up to the numerator. Now, the one thing I notice is that now I have an x to the second and an x up there. So this would be applying a rule that we've learned in the past. If you have the same base, remember you have to add your exponents together. So I'm going to write my -4. I'm now going to add my exponents together. So 2 and 1 give me a total of 3. And then I'm going to keep the 2 on the bottom. Now, the last thing I want you to always look for is if you cover up your variables in the problem and you look at the larger numbers in the problem, like the -4 and the 2, I know if I punch -4 over 2 in my calculator, or even if you just think about this, -4 over 2 will simplify down to -2. So this problem will continue a little bit further. So you always want to double check the numbers in the problem and see if they simplify. So -4 over 2 simplifies to -2, and then I'm going to just write x to the third power. So there's the final answer for question number 1. Okay, for question number 2, the only thing with the negative exponent is the m to the -2, so that would go up to the numerator. So the 8 stays in place. The m to the -2, you move up, but with a positive exponent. Since you've taken everything from the denominator, you can put a 1 as a placeholder. But remember, anything over 1 is just itself. So the final answer is 8m to the second power. In question number 3, the c to the -10 is the only thing that has a negative exponent. So the 1 stays in place, the 4 stays in place, and the d to the 12th stays in place. The only thing that moves is the c to the 10th, and that goes up in the numerator. It's technically simplified down, but if you wanted to make it even better, 1 times anything is just itself. So we would just make that c to the 10th, and then 4d to the 12th would be the final answer for question number 3. All right, so when you look back at today's lesson, most important ideas: do you know how to move a negative exponent? The first concept of it is we put 1s underneath it and flipped it if it wasn't a fraction. If it was set up like a fraction, we moved floors, right? So if it was in the numerator, we moved it to the denominator. If it was in the denominator, we moved it to the numerator, just like in these examples. And then the last idea that we had for today was that if you had 0 as an exponent, remember, anything raised to the 0 power is 1.